Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on viscous resistance on journal bearing. In our last lecture, already we have discussed the theory part and the derivation on viscous resistance on journal bearing, and we have found the power absorbed by the shaft. So now, based on that, we'll solve a problem on that. So here I have taken a question. A shaft having a diameter of 50 mm rotates centrally on a journal bearing having a diameter of 50.15 millimeter and length is given 100 millimeter. The angular space between the shaft and the bearing is filled with oil having a viscosity of 0.9 poise, and determine the power absorbed in the bearing when the speed of rotation is 600 rpm. So these are the data given for us. Now based on the data, let me draw a diagram for this. So let's consider this is the shaft and the shaft is rotating and we have the bearing to this connected to this shaft, and between this bearing and the shaft oil is there to make the shaft in perfect rotation. So it was there. So now the data given, diameter of the shaft is given here. So let's see, this is the diameter 50 millimeter, and diameter of the bearing is also given. This is given 50.15 millimeter. Okay, and the oil which is used in between this shaft and the bearing, okay, that is given 0.9 poise. Okay, and the rotation of the shaft is given 600 rpm. So let's write down the data given here. So the data given for this question is diameter of the shaft is given 50 millimeter. So this one we can write 0.05 meter. Okay, so this is what I have done, like I have converted this millimeter into meter. And next is diameter of the bearing. Diameter of the bearing is given 50.15 millimeter, is nothing but we can again write 0.05015 meter. Okay, and next is the length of the bearing. That means from here to here, what is the distance covered. Okay, actually the bearing can be full length of the shaft or maybe half length or partial length, anything can be possible here. So this is given 100 millimeter, is nothing but again we can write 0.1 meter, and the viscosity of the oil is given, that is mu equal to 0.9 poise, and this also we can convert into meter square. That means divided by 10 we can do. So 0.9 by 10 Newton second per meter square. This also can be written, and the speed n is given 600 rpm. Okay, so all these things are given. Now we need to find out the power absorbed in the bearing when the speed rotation is 600 rpm. So this is all about the data given for us. Now as for this question, we need to calculate power absorbed. So the power absorbed formula we have seen in the last lecture, that is nothing but 2 pi nt by 60. So in this equation, if you see, all these values are known, like 2 pi n is given t. Torque is unknown to us. So the torque is nothing but, we need to calculate the torque. How we can calculate? Now what is the force applied and the distance. So distance here we need to consider the radius of this shaft. So the force which is applied. So here actually the shear force need to be considered for this, and the shear force which is applied and the radius of the shaft, or we can write force into diameter of the shaft by 2. So the force is nothing but the shear force, as I told. So shear force, again, how to calculate, because this is also not given. So shear force you can calculate by using the formula shear stress. So shear stress into area, because we know that shear stress equal to shear force by area. So we can write shear force equal to shear stress into area. So area is what? The area of the shaft. Okay, total shaft. So that is nothing but pi dl we can consider. Okay, now here tau again need to be calculated. So tau value again, tau equal to, we know the formula as per the Newton's law of viscosity. We can write mu into du by dy. So mu value already given. So now next come to the du. So du is nothing but here, for this condition we have considered like a du equal to change in velocity and change in height or change in thickness. So du we can write here the speed of the rotation, the speed of the shaft. So that is nothing but the tangential speed of the shaft. We can write v. So for this the formula is pi dn by 60. So pi dn is nothing but d value is 0.05 into n. So pi into 0.05 into 600 divided by 60. So let's find out the help of calculator. Let's consider. So pi value given into 0.05 into 600 and divided by 60. So this is nothing 1.57. 1.57. Obviously this will be considered meter per second. So now this is the velocity. In place of d we can write. Now what about the dy? So dy is nothing but the thickness t. I can write the thickness between this bearing and the shaft. So total diameter is given, bearing diameter given, shaft diameter given. If you minus it and divide by 2, because this side thickness is there, this side thickness is there. So only one side we need to consider. So that means diameter of the bearing, let d1, and diameter of the shaft, let d2, divided by 2. So this is nothing but 50.15 minus 50 divided by 2. So this is, we will get 0.075 millimeter, because this also we need to consider in the meter. So we can write this is 0.075 into 10 to the power minus 3 meter. So we got this value. Now what we'll do, we'll just put this value in the tau equation. So let's write the tau equal to 0.9 divided by 10 into this du. D is nothing but 1.57. 1.57 divided by dy. dy is nothing but 0.075 into 10 to the power minus 3. So let's solve this. So already this value is there. So multiply 0.9 and again divide 0.075, 18.84, again divided by 10 is there, 1.88 into 10 to the power minus 3. So 88, 10 to the power minus 3, it is in the denominator. When you take it to upper, so that will be 10 to the power 3. Okay, so this one we can write Newton per meter square. So if you elongate this value, so you can get 1884.9 we can write Newton per meter square. So this is the value of tau or shear stress. Now let's put this value in the force equation. So shear force equal to, here we can find out this 1884.9 into pi dl, pi into 0.05 into L, 0.1. So let's multiply in this same equation So what I'll do, just multiply 1000 into pi into 0.05 into 0.1. So all total what we're getting 29.6. 29.06. Sorry, 60. 29.60. This is the shear force what you're getting. This is Newton. Now let's put the value in this torque. Again, torque equal to this 29.60 into R or D by 2. So again, just multiplying that 0.05 by 2. So this one into 0.05 divided by 2. So 0.74. 0.74 Newton into meter. This is Newton into meter. So now let's put this value in the power P. Finally, we are going to get 2 pi nt by 60. So again, just to multiply in this is because this is t value, just to multiply into 2 into pi into n value. How much is 600 is there already, into 600 and divided by 60 will be there, I hope. So finally we are going to get this power absorbed, that is 46.50. 46.50, this much watt. So what is the power absorbed by this shaft? 46.50 watt. So I hope you understand like how to solve this problem. You know, the data given means you can easily identify. Only few things we need to remember, like the power absorbed formula, and again how to calculate this torque, and again shear force, then Newton's law of viscosity formula. Remaining all are very simple. Okay, so I hope you understand. If you're having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you all.